Bonsuelo athletes, this is it's kind of a great day. Well, every day's a great day. What is this? This is the end of chapter 1. It's kind of sad, but yet, what does that mean? It means chapter 2 is ahead of us. That makes it a great day. And even just right in front of us right here, we have absolute value inequalities. Just kind of makes your hair stand on end. Doesn't make my hair stand on end because it can't, but we do what we can. Anyway, let's go to it. Okay, if I can just recall something for you, let's talk about absolute value equations for a few seconds. That's not what we're doing today. I just want to remind you, what's the definition of, so I'm going to scribble some stuff on the bottom and then erase it. What's the definition of absolute value? Well, we use the algebraic definition of absolute value, and that is absolute, which you can go back and look at the absolute value equations file if you want, video if you want. But that's absolute value of x equals x or negative x. So what did we do? We dropped the bars and then we dropped the bars and made it negative. We're not going to do that here. We're going to use the geometric definition of absolute value. Now, why is that? Well, what's the geometric definition? First of all, it's the distance from a central point. Why are we going to do this? The last video, which was just on inequalities and interval notation, but on the inequalities, I said you must solve an inequality by graphing. Now, with the exception of a single linear inequality. Okay, well, what we looked at in that video was something that looked like this. Don't write this down. X plus 7 is greater than or equal to, I don't know, like 2x plus 7 is greater than or equal to 21. You don't need to graph this unless I ask you to or something like that. You just subtract the 7, divide by 2. Fine, but what if that's not what we're going to be looking at here? Okay, what if you have something that looks like this? The absolute value of x is greater than or equal to 4. Okay, I don't have to tell you to solve this by graphing. Why? Because this is not a single linear inequality. Now, you could say it's kind of a single linear inequality, but this is an absolute value equation. It's not a linear equation. Remember, how do you tell what type of equation you have? You look at the variable. Okay, this was back when we dealt with equations just in general. Like this is a linear equation. Okay, the variable's just variable to the first power. There's nothing else around there besides it. Besides, just 2x plus 7 equals 4. But if I did this, that's no longer a linear equation. Why? It's an absolute value equation. So eventually I'll define a little more precisely what a linear equation is. But if it's got some sort of mathematical symbol around it besides, just like 2 times x or 3 times x, or even if you have parentheses, that's not a mathematical operation, but absolute value is a mathematical operation. Since this problem has an absolute value around it, this is not a linear equation, it's an absolute value equation. Okay, I'm going to get rid of these. And then we'll start. Okay, the idea is this. I'm going to put an equation on here. We're not doing equations today, okay? But I just want to show you something. I'm going to look at this geometrically in terms of a graph. Okay, what if we have absolute value of x equals 4? Okay, when you look at something, now I would solve this algebraically, okay? There's no need to solve it geometrically. Why? It's not even an inequality. We did this back a couple days ago. We just said x equals 4 and x equals negative 4, right? There's no need to look at this geometrically, but I'm going to just to get an idea across. Okay, when you look at an absolute value geometrically, when you see the absolute value, you should just think to yourself the word distance. So what's this saying? The distance from the center is 4. Okay, well, let's take a look at a number line. Okay, the center being 0. And from 0, I can measure out a distance of 4 two different ways. I can do it to the right and I can do it to the left. Well, what's 0, 4 to the right is negative 4. And 0, 4 to the left, sorry, what am I doing? 0 to the right is positive 4. And 0 to the left is negative 4. So what are the answers to this? X equals negative 4 and 4. Because those are the two numbers that, and I wouldn't write this down, just listen, okay? Because this is not an inequality, so I don't want you to really have it in your notes and look back on it and think somehow you have to do this. This is an equation, okay? But you have a distance of 4 in each direction. So from the center, you're going up 4 in each direction. That gets you to negative 4 and 4, okay? That's looking at it from a distance. Okay, not using that definition that we used before, drop the bars and make it negative, which is the way I would always do an equation, at least for now. Okay, well, I'm going to get rid of this. And now let's start looking at an inequality. Okay, so we have the absolute value of x. So we're saying solve, of course, find all the values that make the statement true. The absolute value of x, let's just go for is greater than or equal to 4. Okay. We have to solve it with a graph. Why? Because it's not a single linear inequality. This is an absolute value inequality. Okay. So from the central, so the distance is greater than or equal to 4. Well, from 0, let's just find the distance that's 4. So 4 to the right gets us to 4, and 4 to the left gets us to negative 4. And we want to include those because it says the distance equals 4. That's what that little equal sign is. But of course, there's more than that. It also says the distance is greater than 4. Well, if 4 is where the distance is exactly 4, where are the distances that are more than 4? Well, from 0, I'm going to write some other stuff on here. By the way, this problem you can copy down. But what I'm going to write down right now, don't write it down. Right here, right here, right here, all these distances are less than 4 away from 0. So I don't want to include those. How about this one? It's still less than 4. Well, how about this one? No, that's more than 4 units away from 0. So I don't want to include, how about this one? Well, that's more than 4 units away from 0, so I want to include that. How about this? All of these ones out here are going to be more than 4, so I want to include those. Okay? So I'm going to get rid of the little x's. You wouldn't have to put the little x's. I'm just trying to show you something. So I want to include 4 and larger. Those are all the distances that are 4 and larger, 4 and more than 4 away from 0. Well, let's look at the other side, though, okay? How about this distance right here? That's a distance less than 4 away from 0. Remember, distance doesn't matter direction, okay? Well, that right there is less than 4. That right there is less than 4, but this one's more than 4 away from 0. This one's also more than 4 away from 0. This one, all of these are a distance more than 4 away from 0. So, and you wouldn't put those x's. I'm just trying to show you something. So I'm going to get rid of them. So what would we do? I'm going to get rid of all of those, and I just want to show where all the distances are more than 4. So it's everything here. That's the graph of the answer. Now, I want to point something. I realize most people think here, oh, greater than means you always draw the graph going to the right. Well, that is if it's just greater than a single number. But here you're saying the distance is more than 4. So all of these distances are less than 4. I don't know why it just made a straight line, but so you don't want to include those. All of these distances would be less than 4. From 0 this way, okay, all those distances are less than 4, so you don't want to include those. But all of these distances out here are more than 4 away from 0. And all of these distances out here are more than 4 away from 0. Okay, that's why we include those. Now, remember I told you at one point, always give the answer in the form of the original problem. So, okay, we've got the answer. The answer is a graph, but that's not an acceptable form. You can give the answer 2 ways. One is an inequality, and the inequality would be x is less than or equal to -4, or x is greater than or equal to 4. Those are all the points that make the original statement true. And I showed you in the last video, how to take a graph and change it into write an inequality. Or the other possibility is to write the interval, and the interval would be -infinity to -4 union 4 to positive infinity. Now, you don't need both of these answers. Either one's fine. If I request one or the other, then make sure you give me that. Other than that, I don't care which one you give me for the time being. Now, how would it differ if it was this? Absolute value of x is greater than 4. Basically, it'd be the exact same thing with one small difference. Okay, so we'd have 0. We'd go out 4 to 4, and we would not include that. Okay, then we'd go out 4 in this direction, and we would not include that. Why? Because it's not greater than or equal to 4, it's just greater than 4. So 4 is where the distance is exactly 4. But other than that, the graph's going to look the exact same. And then how would you write it? Pretty much the same. X is less than -4, or x is greater than 4. Or as an interval, you would do the same thing, except it would be all parentheses. So there's a very, very slight difference between the first problem and the second problem. It's just a matter of whether you include the 4 or not. Okay? All right, let's take a look at another example then. Okay, let's try, let's just keep it kind of simple. Absolute value of x is less than or equal to 7. Okay? So from 0, I'm going to measure out 7 in each direction. And by the way, you don't have to label 1, 2, 3, 4, 5, 6, 7. Just 0 to 7 is fine. And then -7. Well, that's where the distances are exactly 7. And since it says equals, I want to include those. Well, where are the distances less than 7? Well, here, that distance is less than 7 from 0. That distance is, all of these distances are less than 7. So those are the ones I want to include. These distances out here, those are more than 7, so I don't want to include those. Okay? So let me get rid of these kind of scribblings. You wouldn't put these little X's and dots and stuff. I'm just trying to give you an idea of what part I'm going to include. So basically everything between those are going to be any number in here from -7 to 7, including those, would be a solution, would make the statement true. Absolute value of x is less than or equal to 7. And then how would you write that? Again, this is one graph, so I write one statement, x is between -7 and 7. Or as an interval, it'd be -7 to 7 with a bracket. What would happen if I had absolute value of x is just less than 7? Again, It would just be pretty much the same thing. You just wouldn't include the -7 or the 7. So we'd have 0, we'd go out 7 on each side. That would get us to 7 and -7, but you just wouldn't include those because it's not, the distance is not equal to 7, it's just less than 7. And then everything would pretty much look the exact same, except you wouldn't have the equal signs. And on this, you would use parentheses. Okay? Now, at the end of an absolute value equation problem, I said you had to check them. Well, you can't check these per se because there's an infinite number of solutions here. There are an infinite number of numbers between -7 and 7. Okay, well, what if you have this? So as long as you can graph it, you're fine. Okay, well, what if you have this? The absolute value of x is, I don't know, greater, let's say greater than or equal to -2. And then, well, I'll get to that. So here, well, how do you measure out -2? You can't. So again, what you have to do is read what it says. When you see the absolute value around the x, you have to read it as the word distance. The distance is greater than or equal to -2. Well, when is a distance greater than or equal to a negative number? Well, the distance is always bigger than a negative. So there's nothing you can really do to show me this on a graph other than saying this. Where are the distances greater than -2? Because you can't measure out -2 on the graph. It would just be everywhere. Because the distance is always greater than or equal to -2. What would that be? How would you write the answer then? You'd say all real numbers, because there's no inequality for that. Or as an interval, you'd say -infinity to +infinity. Okay, well, what if the problem says the absolute value of x is greater than -2? It'd be the exact same thing. That does not change the problem in the least, because when is the distance greater than -2? It always is. So if you just go and look at this one, that's what you do. Okay, but let's take a look at another possibility. The absolute value of x is less than or equal to -5, let's say. And by the way, if you have the absolute value of x is less than -5, it's going to be the same thing. It doesn't matter whether it's less than or equal to or less than. Okay, again, you can't measure out a -5 on a number line. So what do? Well, let's read what it says. The distance is less than or equal to a negative. When is distance less than a negative number? It never is. A distance is always something that's positive. So when is a distance less than or equal to a negative number? Or when is a distance less than a negative number? It never is. So you can't graph anything. So what would you put? No solution. Or, of course, you could put empty set. Okay, there's no inequality because there's no numbers. There's no inequality and there's also no interval for that. Again, when you're doing this geometrically, you have to read it as you have to read the absolute value as the word distance. Okay? So it's up here, first problem, the distance is greater than or equal to 4. The next problem, the distance is less than or equal to 7. The next one, the distance is greater than or equal to -2, which every distance is greater than or equal to -2. The last one, the distance is less than or equal to -5, which it can't be. It's virtually impossible. So here, again, what are we doing on all these? We're finding all the values that make the statement true. You can plug in to this equation, this inequality on the very first one up here, any number from -infinity to -4 and 4 to +infinity, and it'll make the statement true. On the second one, the distance is less than or equal to 7. You can plug in any number from -7 to 7, and it'll make that statement true. The next one, the distance is greater than or equal to -2. You can plug in any number, it'll make it true. Plug in 5, it makes it true. 20, 13.76498. It doesn't matter what number you plug in, that's always a true statement. That's why all real numbers make it true. And this last one, you can't make it true. Plug in any number you want for x, and you're going to get a false statement. There is nothing that will make that statement true. That's it. It's the end of chapter 1. Just think, very shortly, you'll have the thrill of the test. But for right now, that's some information to digest and think about and ask me questions about if you have it. I hope you've enjoyed these videos, because, gosh, we've only got about 150 more of them to go. Actually, I hope that's not true. I hope pretty soon you're going to be back in the room, but you never know. Anyway, have a great day.